If you try to use your computer in the shower, that's going to be a problem.
Alright,
Our electrolytes, let's go here.
Non-electrolytes. Compounds that conduct an electric current in aqueous solution or the molten state are electrolytes. Compounds that do not conduct an electric current in aqueous solution or the molten state are non-electrolytes. When a weak electrolyte is in solution, only a fraction of the solute exists as ions. A weak electrolyte is a solution in which only a fraction of the solute exists as ions. When a strong electrolyte is dissolved, a large portion of the solute exists as ions. A strong electrolyte is a solution in which a large portion of the solute exists as ions.
So ions is an important thing because they're either
the charged atom.
Exactly, and charge, electricity, charge, all makes sense. That's really, really good. I like that idea. When it says molten state, what does molten mean?
Molten just means like melted form, which is therefore a liquid. For example, iron ore is molten iron.
Okay. Well, the ore itself is solid, but if you melt it, and it becomes that gooey liquid lava.
Well, yeah, you know what I mean is whenever you see it in the mold, that's
exactly,
molten.
exactly. And so, and you think about it, gee, if I could cook up a bunch of iron in our classroom right here in that molten state, and I dropped a solid piece of iron in it,
it's gonna melt.
Yeah, but it would melt, but the solid piece would drop to the bottom and then melt. But
depends on how deep it is, I guess.
Well, it's going to definitely melt until it dissolves, until it melts, right?
Yep.
The same thing kind of happens with an ice cube. I drop the ice cube in the water, it floats until it dissolves. So that's what they meant about that heat of vaporization and heat of ice capacity. Who would like this one?
You're gonna have to fix something. And I'm having a lot of these problems.
There we go.
No, you couldn't add that as your background.
That's what I did, however, it just appears in the front sometimes.
You know, I'm not sure why that happens with PowerPoint. I think
it's just one of those errors, you know.
It's one of those things that occurs, and I think it might be a fault in the program. And sometimes people run into music problems, and they try to fix certain music problems.
Yeah, computers just have computer errors, you know.
Yeah.
It's just one of those things.
Yep, but we could do it.
Alright, suspensions and colloids. The suspensions are mixtures from which some of the particles will settle slowly upon standing. Colloids are mixtures containing particles that are intermediate in size between those of suspensions and true solutions. The Tyndall effect is the scattering of invisible light in all directions. The chaotic movement of colloidal particles is called Brownian motion. Motions are colloidal dispersions of liquids in liquids.
Now, this word Brownian motion. Brownian motion means almost like kinetic energy. Kinetic energy, the particles move into their various states. So Brownian motion, let's go back to that slide there. Brownian motion is basically saying that the molecules travel in a random direction.
Oh, good.
Flipped around.
Brownies.
A good example of suspension, like if you took like a can of Coca-Cola, it's a true mixture, it's homogeneous, it spreads out evenly. The suspension means you got little particles, and eventually some of them are going to settle to the bottom. You know, like sugar, melting sugar in hot coffee. As coffee cools, the sugars are suspended there in the liquid. Eventually they're going to fall to the bottom if you put too much sugar. Like if Dunkin' Donuts, you ask for an extra sweet thing. And then the emulsions, or the colloids, are basically things like water. I'm sorry, milk. If you take milk and eventually leave milk, what do you have? Spoiled milk. And what happens in the milk is the top part is the liquid, and eventually all the heavier particles of the milk settle down. The fats, the proteins, the sugars, and that kind of stuff. Well, it was worth the effort of getting that from that computer onto that computer and showing it to us.
Okay, thank you.
Nicely done, Chris. Nicely done, Adam. This little Tyndall effect also is kind of like, remember, light, everything reflects light in different patterns, and if we have a record of the various patterns, we can always figure out what something is made of, just by the way it reflects light. All right, we're done. Look at that, right in time, too. A light alert here.
The light!
Next week, guys, Mari, Beatrice, we're going to try to get yours done, okay? I know, next week. Next week, okay, we'll get yours. And let's see, you've seen everybody's then.
Greg just walked out of the room. Going,
We have all next week, and then 2 days a week after.
that is what I've observed.
You've observed something?
Yeah, Greg just walked out of the room going, Vito.
We like drag him back in here and
Yes. Ow. Seriously?
Do you feel any better? They are headed.
I'm evil.
Oh, it's over here? Okay.
Why not? Over here is awesome.
Actually, see the pencil, watch the way whatever. Okay, see the pen? One second.
Yeah. Cool.
There's the pen.
Cool. Why?
Wait, let me see this. That wasn't me, that was Greg.
Nice. Nice one, Chris. Sorry, I really had to go.
Do you want the original stuff or you want a copy?
Coffee is fine.
What other words do you want?
You guys should really see the look on my face right now.
What the heck? Drive that over the skull.
Hey, what? I will return this to you.
Just burn over the skull.
No, it's already it was already there.
Okay. Did anybody have any questions on what we did the other day about comparing two decimals? Greg, did you have any questions?
No?
Ashley, Beatrice?
No.
We're going to have a little quiz on Monday. So I'm just going to go over a couple of things today. And it's all going to be about what we've been doing for the last week and a half. Okay? Everything was done. Press.
What?
I get paper again. But just don't.
Hey!
Jingle bells, and late.
Greg, how would I read that number?
5
What do you do?
and 3,400.
Excellent. This is how I would write the number, because on the quiz, Mari, pay attention, okay? Mari, you're going to have to write this out. This is 5 and 34 hundredths. So I would write it 5 and, because whenever we have the decimal, we can substitute